My name is Chuck, and I work at MapZen. And if you haven't heard of MapZen, we are a small company based here in New York, and we build open source tools and services for mapping and location-based apps. We also collaborate with other organizations and companies and governments to try and get more geo data into the public domain. So we're coming at mapping from a very kind of aggressive open source angle. And in a lot of the work we've done on Android over the past few years, we've attempted to explore the areas of testability and clean architecture. And so this talk has really come out of a lot of the work we've done at MapZen in the past few years. And so you're probably wondering about the part two, and you're like, oh my gosh, did I get here late? Did I miss part one? So I originally gave this talk at DroidCon back in September. And I didn't want to just do a straight rehash of that, but rather, maybe take some of those concepts and ideas that I spoke about at DroidCon and sort of evolve those and take them one step further. And in particular, I got a lot of really good feedback and thoughtful questions after the DroidCon talk, which I want to address specifically as we go through the presentation tonight. And so the first half will be a bit of a recap of DroidCon. The second half will be some of these advanced ideas and use cases around clean architecture and testing. All right, so let's get started. So normally, I've been doing Android for a long time, and I've been doing unit testing for a long time. And so normally when I would give a talk about this is the point when I'd get up on my soapbox and start to preach to everybody about why you should be testing your applications and why this is important. But I don't really feel like I have to do that as much anymore in the Android community, which is actually, a really good sign. I feel like Android development is starting to grow up. We're starting to mature to the point where we are thinking about things like testing and clean architecture in the way that other realms of software development have been doing for a long time. And so really what it comes down to is, we're talking about quality. As developers, we want to take pride in our work, and we want to be sure that the applications we're building do what we expect them to do. And we want to be able to verify that in some kind of way that's not necessarily painstaking manual testing all day long. And so as you might have heard, there's a variety of tools available now for testing on Android, and it hasn't always been this way. So the fact that we have such a plethora of tools to choose from is a good thing. At the same time, sometimes, when you have too many choices, it can lead to a bit of analysis paralysis. And so we're going to go through some of these tools, and not only that, but how you can best structure and build your applications to maybe take advantage of them a little bit better. And so besides testing, clean architecture is another one of these things that's, as a concept, has been around in software development for a long time, but recently has seemed to have taken on more of a prominent role in the Android space. And so when we're talking about clean architecture, what are we talking about? Things like model view controller, model view presenter, model view view model. These are all different kind of design patterns or a combination of design patterns that allow you to lay out your code in maybe a little bit more structured and modular way, and hopefully reap some benefits from that. But before we get into all that, I want to take a step back for a second, and let's go back in time and think about when you built your first Android application. Okay? Well, where did we all begin? Typically, you're going to begin with an activity, right? That's the basic building block of most apps. And well, what does the activity do? All right, so at a basic level, it does a few things. It's going to interact with the framework or the operating system through the Android lifecycle, and it's also going to give you access to these different system services, whether it be the location manager or other components built into the system, notifications, different hardware sensors, things like that. And well, most applications are going to have some sort of UI associated with them as well. So let's pretend that in our activity here we have an edit text and a button, and then, well, maybe our application is going to want to call out to a web service at some point, and maybe it's also going to want to cache some data locally so we can persist that. Well, we all know as good developers we don't want to be doing that on our main thread, so let's spin up an async task and make sure that we're not blocking the interaction with our edit text and our button while we're doing that. And then at some point, Fragments came along. And Fragments were meant to simplify and break down some of the UI components. And specifically, when tablets were introduced for Android, Fragments were kind of a vehicle for us to make our UIs more adaptable, right? And possibly make them a little bit more reusable, depending on whether you're dealing with configuration changes or different form factors of a device. Well, so the upside of Fragments is totally there. At the same time, when you introduce Fragments into the equation, you've got a little bit of complexity that's added to your system as well. So now we have not only the activity lifecycle to manage, but we have the fragment lifecycle to manage as well. And then, of course, your user is going to be interacting with your application. It's not just going to run in a vacuum. They're going to be doing things you don't expect them to do. So there's going to be user input coming in, and you need to validate that input and make sure it makes sense in the context of your app. And then let's not even get started with what you have to deal with when somebody finally rotates the device and all of this gets blown up and you have to recreate it, right? And your activity is destroyed, and maybe we can hold on to our fragments by retaining their instance, but there's some gotchas associated with that as well. And so what we wind up with is a whole lot of complexity that we're trying to manage. And now let's think about, as a developer who wants to actually write some unit tests for this. How are we going to do that? Oh, sorry, I skipped one thing. If you wanted to start a new activity, you'd fire off an intent with some parsable extras. And then we were given this thing, and this is going back because I realize this is deprecated now, but we were given this thing called Activity Instrumentation Test Case 2 and said, okay, now write a test for all that. And I was like, huh? And so actually, Activity Instrumentation Test Case 2 was just deprecated in Marshmallow, and so it's been around for a while, but hasn't really been widely used for a long time. And a lot of that's due to the availability of mockable Android jars and other things we're going to talk about in a bit. But this is kind of what we had for a long time in Android, and it's understandable why a lot of developers would not want to venture down the path of automated testing when this is what you're dealing with. I mean, basically, it's one big tasty burrito, right? Imagine if you get to the end of the line at Chipotle and you went through and got all your fixings and all your toppings, and then right when you're about to check out, you say, "Oh, wait a minute, you know what? I don't think I want white rice. I actually wanted the brown rice." Well, what are they going to do? They can't take the white rice out and put the brown. They're going to have to build you one from scratch, and that's kind of what we had to do with our apps anytime we wanted to make a change. So there has to be a better way. Well, so let's go back to our original diagram here, starting with our activity. But let's take the first step to try and make this a little bit easier to manage, and let's separate our activity and our logic, right? Seems like a good thing to want to do, considering how many responsibilities the activity has. Maybe we don't want our business logic all mixed in with things like the Android lifecycle and the system services. Well, if we're going to separate our logic, well, then maybe we'll take the next step as well and separate our data. And then this is where things start to get weird, because in Android land, we don't, like in a lot of types of software development, this might be, you might be dealing with a three-piece system where you have model view controller and model view presenter. But in Android, we really, the concept of a view and the concept of your activity are really two separate things, or at least I like to think of them that way. I like to use a lot of compound views and extend linear layout and add a bunch of, kind of build things component-wise like that, and not necessarily have a bunch of one-off views running around in my activity rather. And so I like to think of the activity and the view as a separate thing. So then, looking at this kind of mental construct for how to break apart our application, then the question becomes, what do we call these things? Well, so we can call, if we want to try and apply model view controller, we can call the logic the controller, the data can be our model, which seems pretty obvious, but then we're left calling the activity the view, and well, given that we have all these other things called views in Android, that doesn't feel quite right. Same thing if we want to apply model view presenter, or even model view view model. Now, I'm not trying to suggest that all three of these are the exact same thing, because they're definitely not, and there's a lot of nuance in the flow of information and the way that they connect to each other, as far as when you're talking about a controller versus a presenter versus a view model. But what I am trying to point out is that given this 4-object world that we have in Android, none of the 3-object design patterns or architectures really seem to fit to me. And that reminds me of this great quote from Phil Carlton, which is, figuring out what to call things is really only one of the 2 hard problems we have in computer science. And so it led me, and the other engineers that I work with in MapZen, we got to a point where we said, all right, well, who says you're only allowed to have one or the other? What if we had a presenter and a controller? And so we gave that a try, and we said, what if we call the activity the controller, and we call the logic piece our presenter, and then just let the view be a view, like views naturally want to be views, right? So let's let them be views. Now, this next piece here is pretty key to the whole thing, and that is we actually want to put our activity behind an interface. And so really the idea of a controller is going to be an interface that our activity implements. And this is going to be important when we get into the testability part. Now you can see as we start to add back in all the other pieces we had in our tasty burrito example, each one of these components has fewer responsibilities and things aren't nearly as nested as they were before, and we have some separation of concerns, and hopefully we can start to interact and evaluate and validate these different pieces in isolation. And so what this also does for us is it gives us a really nice, neat dividing line where we can just draw a line right down the middle and say this half of our application cares about Android, and this other half does not. And so we eliminate the dependency on the Android framework from everything that's on the right half of the screen. Well, and what does that do? It allows us to employ 2 different testing strategies for the Android dependent and the Android agnostic portions of our application. And so first I want to talk a little bit about how you can approach testing your models and your presenters using just pure JUnit and Mockito. And so what we're going to do here is we're going to eliminate all the components that care about Android, and we're going to replace our activity with a test controller. We're going to build a dummy class that implements our controller interface, and that's what our presenter is going to talk to while you're testing it. Similarly, we want to actually eliminate our dependency on the network and on the file system, and so we're going to mock our service, our web service, and we're going to also mock our persistent storage. And then one other thing I want to point out here is that, when we were doing the original version using Async Task to connect to our web service, we replaced that with thread in the recent example. And one reason we did that is because Async Task is an Android component. We want to get rid of Android in this half of our app. And the other reason is because we want to be able to actually run our network code synchronously when we're testing. And so what this allows us to do is we can just call run, the run method on our runnables, and run it synchronously while we're testing instead of actually kicking off that other thread. And it makes it way more testable. And again, we're still not hitting a real service, but at the same time, we don't want to introduce any concurrency into the unit tests. And why? Because that is what the rules are. There are actually rules for unit testing, and it's important to be aware of them. So I love this list of rules. It comes from originally from a 2005 blog post by Michael Feathers. I told you a lot of this stuff predates Android itself, but was also worked into his book about working effectively with legacy code. And so right away you can see the first 2 rules there. Using Mockito, we want to mock our database and we want to mock our network connection, because if we spoke to either of those live as we're running our unit tests, then all of a sudden it's no longer a unit test. It's more of an integration or an acceptance test. And then, okay, so given that, how can we approach testing our activities and our views? Well, there's a few different ways to do it. You could use things like Espresso, has become pretty popular over the last few years. There's also UI Automator, which is a little bit more for testing interaction between multiple apps, but could be used. We certainly don't want to use the activity instrumentation test case 2 anymore. Personally, I prefer using Robolectric for testing my activities and my views. And so this is a project that actually runs a lot of the Android source code locally in your JVM and then just mocks out all the low-level components that would actually be trying to interact with any piece of hardware or something that only exists in an actual device or emulator environment. And what that does is it allows you to still run your tests very quickly without having to deploy into the device or emulator environment. And so what does that look like on this half of our app? So instead of a JUnit test runner, we're using the Robolectric test runner, and we're hooking that up to our activity. It also has a mocked version of the runtime environment, which will give you test versions of the system components you might need to interact with. And then we're going to feed some simulated input into our view and make sure it does the right thing. The last bit about the stub presenter isn't even really necessary. Like, you could run your actual presenter code when you're running your tests against your activity. But if it's doing anything heavyweight or long running, then you probably want to stub that out as well. And so I actually put together a sample project that kind of lays out very cleanly in a very simple way some of these concepts, which if we have time at the end, I'll pull up the code on GitHub for you, but you can check that out at ecgreb/mvpc for Model View Presenter Controller. Okay, so this is the point where I would have gone into like digging through some of the sample code at DroidCon, but here's where I want to actually share a few of the questions and the feedback I got after DroidCon or at the talk and afterwards in conversations I had, and address some of those questions about some of the corner cases or the different use cases that came up. So the first one is, what is the best way to manage the presenter scope or the life cycle? So really what this question is getting at is, do we want to tie the life cycle of our presenters to our activities, aka our controllers, or do we want them to persist? And well, the answer is it depends. So you have a couple of options here. One would be to set up your presenter as a global singleton that just lives through all your configuration changes and all the different flows of your application. And this can be great because it makes it easy to maintain your state, but also you can incur some performance costs there in that if you have a lot of different activities and they each have a presenter and they're not lightweight, then those are all going to persist throughout the entire lifetime of your application. And so you might want a way to shut them down. Well, then you might actually want to scope them to, the same life cycle as the controller or the view or the activity that they're tied to. And so, but when you do that, then you have to take some extra care to maintain your state, especially on configuration change. And so in that case, I would recommend introducing a special model called a view state manager, which would persist through the configuration changes and through the various lifecycle events that could be used to rebuild it when you restore from some sort of paused or resumed or destroyed state. And so what would that look like? If our presenter was going to persist through a configuration change, so naturally our activity and our views are going to get rebuilt when you rotate the device. However, the presenter in the model will persist, and that will allow you to maintain your things like network connections, and then also your presenter will know what the view state was when the activity was destroyed, and it'll be able to rebuild it after it comes back. Well, in the alternative, where we want to scope the presenters to the activity, then we need this other object, the view state manager, which is hopefully more lightweight than our presenter, that we don't mind persisting through these changes or through the various activities of the app. All right, so second question, can a view have its own presenter? And the answer is absolutely. So this is really the simple use case of a model view presenter pattern. And so, we don't have to worry about the 4 components. If you want your view to have its own presenter, that's great. And it actually simplifies things a whole lot. And then each view could have its own presenter. So for example, if we wanted to pull that input validation step out of our actual view and put it into its own presenter, that's fine. And that presenter can only live as long as the view does. And take care of all that for you, and that will allow you to separate even more of your logic. And if you have some sort of complex input validation, well, now we can test that with JUnit, and we don't even have to worry about anything like Robolectric or Espresso. And then the third question is, how do you communicate between multiple presenters? And so for this, I'm going to rely on a scenario that comes from an actual app that we've worked on at MapZen. So really you have 2 options here. You could either quote unquote pass the message around the horn through all your different components, or you could use an event bus. And so what do I mean by that? So let's pretend we have a main activity, and this actually comes from an app that we built that's a mapping application. And so our main activity is long-lived. Basically, it's always alive throughout the entire life cycle of the app. As long as you have this app running, the main activity is alive, and so is the main presenter. Then we have various overlay views that come on top of that, like a facility for searching and displaying the results, and then also the idea of doing some sort of routing or navigation. And so each of those views are complex enough that they have their own presenter, right? You with me so far? Good. So let's say something happens in your navigation presenter that actually affects the search presenter, or something, you get some input in your navigation view that needs to affect your search view. For example, there's an exit button built into your navigation view that then is going to exit your routing mode and put you back into some specialized version of the search that allows you to get back into routing. Well, so now all of a sudden we need to pass information that's coming into navigation all the way through to search. And so the one way to do this would be the user inputs, clicks on the close button in navigation view. That event gets passed to the presenter. The presenter says, okay, we need to shut ourselves down, and we need to let search know that they need to update. So then that gets passed to the main activity, which again, we want to pull our logic out of our activities, so that gets passed to the main presenter, processes the logic, puts it back to the main activity, passes it to the search view, which passes, you follow me, right? It literally touches every single thing on the screen. And so maybe that's great, and there's a good reason to do that workflow in your application, or maybe you just kind of want to shortcut all that and add an event bus. And so typically when we use an event bus in our apps, it's going to be to communicate between the various presenters, and that's one way to short circuit that whole process. If there's something you need to get in short order from one of your views presenters to another one, this can be a useful mechanism to do it. So the last thing I wanted to throw out there is this is actually an application that we built at MapZen called RacerMap. And this is literally the project that kind of led us to down a lot of these paths of exploring these different architectures and these testing strategies. And so if you want to check it out, like I said, everything we do is open source. And so you can go to the code on GitHub, on the MapZen organization. RacerMap is all there for you. And one other thing is, if we look at the language stats here, if you're interested in Kotlin, we've actually built this app primarily using Kotlin from the ground up. So, through all the trials and tribulations of the different pre-launch releases. And so, yeah, I would love to get your take on it if you want to check it out. So in conclusion, you're probably wondering, all right, well, we talked about a few different strategies here. What should I use for my app? And really, it comes down to your use case. You know, maybe there's sometimes you need a presenter that persists throughout the entire life of the application, like we do, the one that handles our map, because that's always there. Or maybe your application is a series of, many different activities with a very complex flow, and you need to be more careful about managing the life cycle of these objects. So really, the way you want to set up this sort of architecture depends on your use case. And then once you figure out what your use case is and what your architecture is, well, then figure out how to write your tests so that it actually, your architecture is working in concert with your tests and not working against it. And then finally, my last piece of advice would be, don't be overly dogmatic. There's a lot of theory and principles involved with these sort of design patterns and approaches, but if you get a little bit too to the letter of the law, then you're going to actually create more problems than you solve. And so be willing to be flexible and let your design evolve as you build your application. Now, it's a lot of information and it might seem a little bit overwhelming, but I think if you start to take the first steps, whether you're starting a brand new project or if you're maintaining some sort of legacy code base, just take small steps and you'll see things start to fall into place and kind of make a little bit more sense. And hopefully it will eventually lead you to an application that's more maintainable, more readable, and more testable. And I guess my last piece of advice would be, just like with all things, start where you are. Thanks. Do we have time for questions now? Okay. We actually use Otto. Yeah, from Square. Well, then that's something we need to look into. But we started this project a few years ago when it wasn't deprecated, and so we've been on it for now. Yeah. Thanks for the info, though. I knew it was deprecated. Yeah, it's cool. Samit.
You talk about using presenters and sort of making that not dependent on Android and on the Android framework. So you're talking about instead of using an intent service or an async task or any of the numerous ways that Android gives you the ability to do asynchronous stuff, you're talking about using a thread. One of my questions about using threads in Android, you're still running your processes inside an Android process. So the question is, are you using like daemon threads, or do you like, how does that play with your whole framework? Because you can, in Java, you can set a thread to daemon or not daemon.
Yeah, so the answer is we're using whatever the default is. We're using plain old Java threads that we just wrap runnables. If we really need to be careful about like how many we're executing at a time or something, we'll use a thread pool executor to manage that. But I feel like the real advantage we're getting is one, separating that dependency on Android so we can run JUnit tests and not have to worry about mocking any of Async Tasks behaviors. And then the other one would be just that we can use run versus start in the test environment to do it synchronously. Yeah.
Thank you.
Thanks. Yes. Sorry, say that again. Can we get him a mic? Yeah.
Wondering what the split of like tasks and responsibilities of the presenter and controller in your architecture are versus the traditional just controller in MVC.
Yeah, sure. So we use the term controller kind of loosely as far as MVC uses it, in that we're mainly just using it as an interface to hide our activity behind. And so it's mainly concerned with like the Android lifecycle events and essentially the things that a context gives you access to, like the different system components and things like that, resources. Other than that, the controller doesn't necessarily assume all the responsibilities that it does in MVC, although it still does deal out commands to the views in some cases. But the main difference with MVC is you have like the circular flow where your view passes input to your controller, then your controller updates your model, and then your view is actually an observer on your model, right? And so the information flows in one direction, whereas for us, the information flows bidirectional. And this is the same way it works in standard model view presenter, in that the presenter acts as the middleman, but your model and your view are never communicating directly or observing each other. Yeah. Thanks. Other questions? Yes.
So based on your diagram, it seems like your view is, your model and presenter is totally isolated from the Android. So does presenter know activity at all? Like your Android context?
Yeah, so typically the presenter won't know about the activity or the Android context. That's kind of why we put it behind that interface, is in order to hide it. Now there are a few times that the model has to reach across that boundary. Say for example, you want to use shared preferences as your way to store, persist the data in your model. Then sometimes you have to cheat and reach across that boundary. And then in that case, I would say just have an interface for it, the same way we did with the controller. Hide your shared preferences access behind an interface. Use the real shared preferences when you're running your production code, and then have some test double in your unit test environment. Yeah. Yeah. I mean, another tool that we rely on a whole lot when we do this is Dagger 2, and so we'll be able to inject different versions of our dependencies depending on whether we're running production or the test harness. It also helps out with the scoping. If you want to scope your presenters to your activities, Dagger's a great tool to do that as well.
Can I ask a question?
Yeah.
So one of your slides had something. Yeah. One of your slides said something about don't be dogmatic, but do you find that trying to mock out shared preferences, which is something that really doesn't need to be tested when you could just use Robolectric, do you find that to be dogmatic to an extreme where it just doesn't serve a purpose to make the code like too little windy to like get at a thing that is like it's not going to affect the overall testing? Like, why don't you just access the shared preferences directly? You know what I mean?
Yeah, I mean that's kind of the balance that you need to strike. And that's a good question. To be clear, we never want to actually be testing shared preferences itself. We just want to be testing the way that we interact with it.
But it's
Yeah.
at the point where it's like if there's something actually wrong with shared preferences is going to be perfectly executed. So you're also not worried about it failing. So mocking it out seems.
Well, on the device,
That's it.
sure, it will always be perfectly executed. Maybe except if you have my phone. But no, nothing against the Robin.
Do you understand what I'm asking?
No, I get it. And
It's like complicated.
yeah, no, you're introducing complexity, and I think. So the reason it's worthwhile, you're saying you could just use Robolectric, for example, if you run against the mockable Android jars with pure JUnit, shared preferences is going to fail. It's going to return some default values, right? And so if you use Robolectric for that, all of a sudden you have the overhead of downloading the source and spinning up their runtime environment, whereas pure JUnit would be way quicker.
Okay.
Is that?
I don't know. You want let's square off, and then we'll
Yeah,
we'll wrestle about it.
It's
I
a
don't know.
trade-off. It's a trade-off.
I don't know. Okay,
Yeah.
fair enough.
Okay, thank you.
Good job. All right. Next up, Mobile Platform Independent Architecture by Dan Leonardis. You ready, sir? All right. This is where I earn the big bucks because I have to MC in between the screen swap outs. I got nothing though tonight. So how's everybody doing? Hey man, it's good to see you. How you been? What? Oh, thanks to the Oscar folks. Woohoo! And Olivia. What? Well, does anybody want to have a T-shirt thrown at them? The problem with the T-shirts is sizes, so I really don't know. It doesn't matter. Anyway, here's Dan. Woohoo!
Am I on? Can you guys hear me? All right, great. So the nice thing about going second is that somebody plows the road for you. The hard thing about going second is someone has already plowed the road for me. So some things might be duplicated, but I'll take a feel from the audience and then I'll play it by ear. So I'm going to talk about mobile platform independent architecture. I've developed applications for Android and iOS, and I started to find out that there are a lot of similarities, and if you're willing to talk to the other side, the other platform developers, you can actually develop independent platform architecture. Can you guys hear me now? Good, I'll keep it to this point. Okay, so most times developers act like this. iOS is on the other side of the fence. I don't speak to them. Android's on that side of the fence. No one speaks to each other. At the end of the talk, we're going to be all like this. And the reality is we need to act like this. Why? Because most businesses today release an app with similar requirements. It's not an iOS app. It's not an Android app. It's just an application. So specifically, we're going to talk about where it starts, the business requirements. We're going to chat a little bit about testing and how it fits into clean code. So again, plowed some of the road for us. We're going to talk about the base architecture patterns. Again, some of it was spoken about earlier. But then we're going to dive into an example of how I was able to actually execute this on the NHL application for when NHL came to Major League Baseball and said, hey, build us an application that can stream video. So it all starts with what? You have to know what you're building. So the product owner's job is to describe what the requirements are for the application. They have to answer what does this app do. They create the use cases or acceptance criteria that describes the app's behavior. With each use case small and well-defined, us, the engineers, can then create the business logic. The business logic is independent from the user interface implementation. That being said, we have to make sure we know what we're doing so we could talk to, all right, how to break these requirements down to software requirements. What's the design going to be? So it all comes and starts with, what are we doing? What we don't do is we don't just start coding right away. We have to think. So you really should be thinking architecture first. How do I put some of our major pieces together? What are my major requirements? How am I going to put those major requirements together? So we did talk earlier from Chuck that we talked about the model view controller. Basically, the purpose was to divide the application into 3 interconnected parts. But we know that the problem is an activity, a view, or a controller. So since much of the application logic depends on not being in the model of view, it ends up being in the controller, which creates massive view controllers. We also just talked about testing. So the problem is if we have massive view controllers, how do we test this? iOS tests this with a sim. We all know if you've used the Android instrumentation tests in the emulator, it's, run it, go get a beer. So we want to see if there's something better. And what's been talked about in the community recently has been clean code. And I am lifting this from Uncle Bob's website and clean code book, but I feel like it's the best description of clean code. So clean code architecture aims at making as much of the business logic testable while looking at everything else as a plugin. This architecture works by implying the dependency rule, which states that the source code dependencies can only point inward. Nothing in the inner circle knows anything at all about something in the outer circle. Enforcing this rule means that crossing boundaries should be done by passing simple data structures between the two using interface relationships such that source code dependencies resist the flow of control. All right, so I know there's a lot there with clean code, but it's a massive subject on its own, and what I want to do is get focused into, assuming we know that, how can we actually implement it? So now the question is, all right, we talked about clean code, now what? Well, with Model View Presenter, again, we all just heard about this, the idea is to separate out the presentation layer from the logic so that everything about how the interface works is separated from how it's represented on the screen. This improves the separation of concerns, aka it silos our business requirements. That's Android. Let's look at iOS. iOS talks about Viper. That's their architectural pattern. Viper separates the presentation layer from the logic layer so that everything about how the interface works is separated from how it is represented on the screen. This improves the separation of concerns, aka silos those business requirements. It's the same thing, just using different language. The idea is to separate out those use cases. Now, I said it before, and a lot of developers, just didn't believe me. So they would say, all right, prove it. So for MVP, here's a detailed diagram. So the entities here are models. So we have the M, that's our entities. We have the V, that's our view controller, and the P is our presenter. Everything on the left side, everything on the left side for what you're seeing is basically what was talked about earlier, where that's our Android dependency material, and everything on the right, that's our internal business logic. That all could be tested. Here's the Viper detail. Looks real similar, doesn't it? Here, the wireframes are basically the routers. So V, view, I, interactor, you kind of get where I'm going. What are the routers? What are the wireframes? Those are the view controllers in iOS. All right, so what I just showed you with the 2 slides was basically the architecture is the same. And what I'm going to do here with an example of NHL is I'm going to try to cover all the bullet points. So even though I've mentioned MVP and Viper, I'm not going to go into examples of how we use that. I'm going to go into an example of how we talked about a high-level discussion of the requirements and broke that all the way down into an architecture that was basically platform independent. So at the beginning of a 4-month crazy cycle to build this application, our requirements looked like this. And this was only our onboarding application, where everything in purple on the left was if you're Canadian, and everything on the right was if you're American. So as you can see, there's many different permutations. There's push notifications, your favorite team, your following team, how do you want to be paying, la da 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 da. Okay, let's start coding. No. All right, so remember, it all starts with thinking, all right? Let's not put everything in a view control and call it a day. Let's think. So what's the best pattern for implementing all these requirements, all these product requirements? Well, the best way to separate our use cases so they're testable is the state pattern. So thank you, gang of 4. The state pattern was the best way to architect the steps of onboarding and launch and we were able to encapsulate all this logic in a state machine using the state pattern. So above what you see on the screen is the UML representation of this pattern. If you don't understand UML, basically takeaway is that the state pattern encapsulated all the varying behavior from the same object based on its internal state. This was a cleaner way for an object to change its behavior at runtime without resorting to large monolithic conditional statements. Don't be that guy. It pays to document your software. All right, so how the state pattern works, even at a high level, is going to save tons of time when you hand off the work to somebody else. Because let's face it, people move on, they get promotions, they go to different projects, etc. So it's much easier to speak to a state diagram, especially when you go over to the other side of the fence, and talk to state diagrams and flowcharts than it is to look at actual code. So that being said, this is the state machine that we had come up with, where the idea is that each number that goes from one state to the next is a separate testable entity. Now we can code. We have our requirements, we have our design documented, now we can start coding. The approach that the Android side took was we went with a little TDD where we wanted to basically write all the tests out for how do we go from different states. We did not know what the view controllers were going to look like. We had no designs the first month. So that's my call out to TDD. It saved us a lot of time. So, again, as a reminder, every permutation, every number on this screen is testable. So, here's what the state pattern was. Now we're going to go into some code, and you're going to start to see Ponzo, plain old next step object, or Pojos, they're going to look the same. Android's first. Here's the setup context. And in the setup context that controls which states we're going, it has a method, process message. Here's our base class for the setup state, and then here's an example of a specific state called splash screen. It gets a message, it knows what to do. Notice how the state handles the knowledge of going to the next state. It's not in a view controller. We could write a test for this. So here's an example of how we wrote a test for a single permutation in the state machine. We set up the state where we wanted it to be. In this case, we wanted to test the splash screen to some unknown state, ABC. Then we perform the test, process some message, and check the state. Plain and simple, no Android involved, just plain old unit testing. Here's iOS now. Here's Objective-C. Here's our Ponzo for the context. Notice it looks exactly the same. We have protocols, those are the interfaces for the context, for the delegate of being able to process. We have the SetupContext class itself, and then they called it setCurrentState with additional code on the bottom. Here's our base class for the state, and below the implementation of the state for the splash screen. Okay, the names are not all the same, but the point is that they were actually able to take all the knowledge off the view controller and stick it into individual states. Here's a few screens. So iOS is on the right, Android's on the left. They all look the same. Here's the paywall, looks the same. We get to the favorite and files screen, it looks slightly different. Guess what? It didn't matter. The state machine, what we developed, the architecture was platform independent. It worked the same way whether you were on Android or iOS because we knew what the requirements were. So knowing what you're building before you start definitely helps creating better architecture. Separating out your use cases gets you into the mindset of clean app creation. MVP and Viper, those design architectural patterns are very similar and they support platform independent architecture. So with the NHL, we demonstrated how we applied this process. So I challenge you guys. I challenge you to think one application. I challenge you to think platform independence. And I challenge you to go to the other side of the fence and, let's build bridges and not walls, right? Does anybody have a question? So the question is, how do I keep track of the activity context? I'll go back to the little diagram I have probably help that out. Okay. So, as stated before, you have multiple choices. You can either say that your presenter is a global singleton, which uses the context of the application. That can get heavy. You can use scoping in Dagger. You scope at the activity level, which means when your activity gets destroyed, your presenter gets destroyed. You have everything hooked in that way. So those are two ways to be able to keep the context in the presenter when needed.
Actually, a thought occurred to me. It was also when Chuck was talking, but it's been a thought that's been going on since Android started. There's no concept of an activity session. So, like, you open an activity, and then the screen rotates, or even now, like, if you change the size of a multi-screen situation or whatever, there's a config change, but the activity, even though it restarts, unless you manually hand things through the bundle, it goes away. So there's, like, we've been having this problem with MVP, where how do you have the same presenter not get killed, but if you rotate the screen, you retain it for that activity without having it attached to the activity class itself. And we've been having that issue.
So one way I was able to get around that, specifically for screen changes, not configuration changes like if you plugged into USB, but that's a separate case. Most of the time you want to be able to hand landscape and portrait. What I've done is I put the most of the presenter calls into the fragments, and in the fragments themselves I said set retain instance state to true, which allows that rotation and that unhooking from the activity, but the fragment never gets destroyed. And because the fragment never gets destroyed, your presenter stays through the rotation.
Which, yeah, that's the endless problem because, like, as Chuck said, then you have your burrito. You know what I mean? Like, there really should be an activity session concept, which there isn't in Android out of the box, which sucks. You know, it's, I mean, anybody that's been doing this for long enough, fragments and activities have this fundamental flaw, which is, you know, that, essentially. So, like, if you click the login button and you rotate the screen, what do? You know? I mean...
Exactly, and then there's other ways around it. Maybe create a private variable that's static for your presenter. That's a way of getting around it as well. There are tricks to do this, but I don't like to use tricks. I like to say, okay, you know.
What do you got, sir?
Oh
boy, here we go.
Well, one other idea that I was playing around with that I didn't get a chance to actually throw into the test app for that scenario is the idea of a class that vends your presenter instances, and then you could give that feedback to say whether or not this is a configuration change or if it's an actual, like, we're shutting down this activity for good and moving on to the next activity in our flow. And then that this way that you know, that manager class could decide whether or not to tear down the presenter or to persist it through the change.
Yeah, we've been doing and I don't like to do roll your own things because they're always bad unless it's really necessary, but it's been essentially attaching a presenter to an ID that gets carried around in the onsave instance state, and you can grab it from the cache or create a new one, and if you're shutting down, it'll shut down if you're not, like, going to be recreated in the near future. So it tries to do it that way, but you only want to do that for things that you really need to. You know, we got burned on an app once where it was like, you go to the user profile screen, like, okay, cool, and then you click on the who's following me screen, then you click on their user profile screen, then you click back, and it's showing the other person's thing because we're using an event bus, and whoops. You know, because you're listening to classes and not to instances. So.
One of the things I noticed.
Well, I'm about to talk about something very interesting. Okay, never mind.
Why not write it in C++ and not have to?
I'll talk about. Well, you can tackle if you want.
I'm going to answer this question with the knowledge that I have too, because I've had to make this case as well, where they would say, "Well, let's go hire some C# guys and do it as a Marion." The concept here is that you're going to have a bunch of iOS developers, you're going to have a bunch of Android developers. When you're doing cutting-edge work, these platforms that you could use, now I'll come back to C++, but these other platforms you can use just aren't fast enough. So for example, The virtual reality came out. Within 1 week, Google had called Major League Baseball and said, we want you guys to host you. Here's a bunch of money. Go do it. So we're not going to, if you're not native, you're out of the scope at that point. With C++ itself, you're running into questions, well, how am I going to marshal data? How am I going to cross that boundary between I got my view with now I got this C++ library that's doing something for me. So it gets more difficult where I have to marshal that data back and forth, where it's easier if I just wrote native to begin with. So places that want to constantly push the boundaries of what these applications do. I mean, Beacon's another great example. When Beacons came out, again, within half a season, they were like, we want beacons in all the ballparks. And guess what? These third-party tools just don't support that technology yet, so you got to build a native, which is the support of a large iOS group and a large Android group. And with the talk I'm giving here, the idea is we could get everybody in a room and double our speed because we're developing this platform-independent architecture.
Development efficiency. That would be my answer. So if you're going to try to do all your shared logic in C++, now you got to find people, or your team has to train on doing C++, and then you have to be able to marshal things back in and out. You're not going to be able to use retrofit or any of the database libraries or any of the things you're normally used to in any of these platforms. So anything you build is going to it has a tax on it, and that's like my argument against it. But then there's a point at which if you're doing duplicate logic to the extreme, that tax gets overwhelmed by the duplicate logic. So it's like a decision on the margin, which is why I've been fixated on this stupid thing that I'm building, which I'm going to talk about for 5 minutes. You know what I'm saying? But that's the fundamental issue. Is like, well, no offense to the Oscar people, like, oh, we're using React. I'm like, okay, so how much longer does it take to build your first thing in React, and how many issues do you run into when you need to do something that's hardware related, or your client, which could be the business person at your company, is absolutely refusing to accept some compromise in the UI that you can't deal with, and now you have to do some native thing and like all this kind of stuff. It's development efficiency that you run into, and especially with C++ or an obscure third-party thing, how many people on Stack Overflow are going to have an answer for you, and then you're stuck for 2 days because you can't get a config thing to work and yada yada. So that's like the argument I have about that, You know what I mean? Like I've been doing Android. That's why I have this phone, the G1. I started doing Android before that phone came out. There was a contest with an emulator. It was like coding for Android before there was a phone. it was an absolute nightmare. But since then, we've been trying to find how do you do like C++ across platform, or do JavaScript cross platform. It was like trying to find like the thing, and everything that comes out generally, it winds up, unless you're doing an extreme amount of cross shared code, it winds up being more costly than just coding it twice, as long as you're careful. And that's the issue. Anyway, yada yada. Clearly I've been thinking about this.
You want to do one more question, and then I'll let you go up? One more? Anybody? All right, thank you, everybody.
All right, thank you. The good news is I had planned on doing more of an extensive talk about the updates, and then business got in the way, so this is going to be extremely short, which is good, because then we'll just get over it. And I'll give you like the announcements. It's very important that I tell you that there is an after party, which we didn't mention earlier. I didn't get the correct pronunciation, and it's Irish, and I'm going to pronounce it wrong, which is really embarrassing. It's like at DroidCon. This might actually crash, but I'll just run it. I don't care. Cool. So at DroidCon, I talked about this thing called, well, there's a thing called J2 objc, which some of you may have heard of, which is Java to Objective-C. Oh, I don't have a connection. God damn it. See, this is what happens when you don't plan ahead. So it's a thing that converts Java to Objective-C, which sounds awful, obviously, right? But we started doing a project this past year that, obviously we've been running an Android consulting company for years. So you really get invested in this concept of like, how do we make shared code something that's more manageable? Because obviously most of Android development company work is taking an iOS app and making an Android app, and you're literally copying the app from one to the other. So long story short-ish. Essentially, there's two conflicting things in your mind, which is you want to do a native app because native apps, are where it's at in the short version, right? For a number of reasons, but also fundamentally, developers don't want to repeat yourself, but you're doing that explicitly for the entire code base. So it's like this cognitive dissonance I kind of couldn't get past. It was always bothering me for years. And then this past year, we started working on this thing called Research Stack, which is the Android port of a thing called Research Kit that Apple produced, which is a medical research framework where you could build medical research apps that are deployed on the iPhone, which is great if you happen to be in the cohort that has iPhones, right? But most of the world does not. So we got a little bit of money to work on the Android corollary, and here we are copying enormous amounts of logic that really doesn't have very strict UI requirements to it, but we're doing it in a platform-specific way when, if the companies that were doing these things just said, you know what, let's forget about, politics and whatever, we could do this in a cross-platform way. So that got to the, hey, let's talk to Microsoft, maybe Xamarin, and nobody was interested. So we just wound up building a great V1 in Android specifically, but that got into the, okay, look, is there a really good option? And it went down the path of finding stuff. So that's a long talk, which I'm not going to give now. This is the Doppel update for people who have seen anything about that talk, which I gave before DroidCon. It's 10-minute slides because I had 10 minutes to make all the slides. So if I actually talk longer than 10 minutes, I think that's like some world record. If the talk is longer than it took me to make the slides up. But the update is basically the video of my talk from DroidCon is up. And I had this thought when I was watching this. This isn't really a talk so much as a meta talk, but you have to deal with it because we run the Meetup, so I can program whatever I want. Anyway, so the DroidCon video is up. There's a link here. I'm going to post all this stuff. There's actually an iOS app from DroidCon that they approved, which I'm going to show you a screenshot in a second and talk about that briefly, that uses this framework that we augmented. And there's a Medium post about the framework and explains my logic and thinking behind it. It's also linked here, and a Medium post about the iOS app. The interesting thing is this is the onboarding screen from the iOS app. And the way this works is our philosophy is that the UIs should be native, but everything below the UI level can be shared, such that you build your Android app, you have a separate Java lib and you module in your Android Studio, and then you have the UI module, and everything that includes your SQLite database, your retrofit networking calls, your RX Java, whatever you want to do that's not UI related should be able to be coded in there with these libraries directly in Java, and then all that code gets converted to iOS with tested and verified library analogs. So the point about developer efficiency is your Android development time is not affected at all beyond having your non-UI code in a separate module. So theoretically, obviously, and not quite in reality land, but and then when you're on iOS land, you can just like copy, you can just draw your UIs and then drag them in, and you have a very narrow layer of UI code. So you're sharing as much as is feasible. Why there is a pug on the screen is that we prepared the DroidCon app, got it to fully functional, and everything below the UI is shared, including the database, the networking, the syncing, the offline support, everything is shared. It's all Android code that's running on iOS. So this app has retrofit running on iOS, SQLite database stuff running on iOS, everything. Apple rejected it because there was a little Android guy on the screen behind the pug, and everywhere that it said Android. So I covered over the Android guy with a sad puppy, and then if you notice down at the bottom, it says sad puppy instead of Android. And I in the code replace every instance of Android with sad puppy, and they approved that. So if you go to the App Store, you can put this on your iPhone, but it's an iOS app that's running retrofit and SQLite database and ORMs and event bus, greens, event bus, everything. So the updates kind of are, you can go to the GitHub repo and like build this thing. And if you have Xcode on your app and your laptop, you can run it and you can see how this works. We were going to have another sample app today, but it didn't happen, largely because I got a little hung up getting the RX Java unit test to work. That's like the gold standard here, is getting open source Android Java stuff to unit test correctly in Objective-C. And the big problem actually is memory cycles. And most things are not that bad with memory cycles because it doesn't have garbage collection as reference counting. If you know Objective-C, RX Java is designed essentially around memory cycles because everything is connected to each other through this whole path. And if there's a medal for having as many memory cycles as possible, RX Java won it. So anyway, that was kind of it's a little hold up. But I want to have, before we have a little more public launch, I want to have RX Java, RX Android. Today we're working on another library, another example app that we're going to launch, which is, what's the name of the company? I think I have it in here. Rybot. They have an Android template which has like everything you ever want in the modern Android app, including like auto value and whatever, all these things. That hopefully the end of the week, maybe next week, we'll have, so you could have all those weird Android libraries running in Objective-C. So that's kind of the goal. Yeah, RX Java is almost 100% passing unit tests, which is kind of surprising. Memory cycles are rough, but only for RX Java. Everything else is pretty good. That's it. We're really still looking for people who want to try this out. Like if you're really weird and experimental, reach out. Because we're looking for like a major app to actually work on this thing with. So that's my update. It really wasn't well thought out. And let's see. Oh, that's right. I was going to run all the unit tests and then show you that it worked. But I forgot that I had the code set up to run a specific unit test. So now it's running all the unit tests. Anyway, yeah, so this is running JUnit tests for RX Java in Xcode in Objective-C. That's what it's doing. So this is the output. Anyway, yada yada, woohoo! I know it's weird, and everyone's like, "No, that sounds awful," but like, it actually works really well. So please reach out. I've been fixated on this for about 6 months. So somebody who wants to play with this, let me know. That's kind of it for the meetup. Don't watch this. It's not that interesting. That's the directions to get here, I guess. All right. I want to say thanks again, Oscar and Amex, for making this event possible. Let's hear it for them. And Olivia. What? Okay.